In this video, I'd like to look at some examples of how we can find the different sides of a parallelogram. Remember that a parallelogram has four important characteristics that you need to learn. In a parallelogram, both pairs of opposite sides are equal, both pairs of opposite sides are parallel, both pairs of opposite angles are equal, and the diagonals bisect each other. Also, just like all quadrilaterals, the interior angles add up to 360 degrees. Let's look at an example. In the sketch below, PQRS is a parallelogram. OT is parallel to SR. PS is equal to 8 meters. PO is equal to 4 meters. And SO is equal to 6 meters. Determine the length of OR, of SQ, and of QT. Let's start with part A. Determine the length of OR. Now, OR lies on diagonal PR, so let's make it red. We know that the diagonals of a parallelogram bisect, so we can say PO is equal to OR. And as our reason, we say diagonals of a parallelogram bisect. We also know that PO is equal to 4 meters because this has been given to us in the question. Now, OR is equal to PO and PO is equal to 4 meters, which means that OR is also 4 meters long. And now let's take out our red diagonal and we can write 4 meters for the diagonal OR. And now we can move on to part B. Determine the length of SQ. SQ is also a diagonal of PQRS. So let's make it red. Let's start with what we know. In this diagonal, we know that SO is equal to OQ because just like we've just seen, the diagonals of a parallelogram bisect each other. We also know that SO is equal to 6 meters because this information has been given to us in the question. Now, SQ is the whole diagonal, so we can see that SQ must be equal to SO plus OQ. SO is 6 meters long. OQ is equal to SO, which means that OQ is also 6 meters long. So we can see that SQ is equal to 6 meters plus another 6 meters, which means that SQ is equal to 12 meters. Let's take out our red diagonal and we can put 6 meters into our diagram for OQ. And now we can move on to part C. Determine the length of QT. QT is part of the side QR. So let's make it red. Now, QR is opposite to side PS in the parallelogram PQRS, but we don't have any information about the position of T, so we cannot use this to find the length of QT. In this section, we may be working with parallelograms, but in the questions we've looked at so far, we have used parallel lines, angle relationships, and triangles. Please make sure that you understand these sections and can work with them, as they will help you when working with not only parallelograms, but all other quadrilaterals as well. We have also said that every bit of information a question gives us is to help us find our answers. The question tells us that OT is parallel to SR. The more you work through questions like this, the more familiar you will become with the different ways to solve them. If you are given two parallel lines of different sizes, They are a good indication we may need to use the midpoint theorem. Now, point O sits on side QS. So let's make the triangle QSR red. Now we can say in triangle QSR, we know that OT is parallel to SR because this information has been given to us in the question. In part B, we also found that QO is equal to OS. We've already proven this, so as our reason, we simply say proven above. This shows us that O is the midpoint of QS, and we know that OT is parallel to SR. So according to the converse midpoint theorem, we can see that T must be the midpoint of QR, which means that QT must be equal to TR. And as our reason, we say the midpoint theorem. If T is the midpoint of QR, then QT must be equal to half the length of QR. So to find the length of QT, we need to find the length of QR. So let's make this whole side blue. QR is one side of the parallelogram PQRS. So let's make the other side PS blue as well. We know that opposite sides of a parallelogram are equal. So if PS is 8 meters long, then we can see that QR is also 8 meters long. And as our reason, we say the opposite sides of a parallelogram are equal. We know that QT is half the length of QR. So if QR is 8 meters long, then we can see that QT is equal to 4 meters. Let's look at another example. In the diagram below, ABCD is a parallelogram. AM is parallel to ON. AC is equal to 10 centimeters. DO is equal to 8 centimeters. And MN is equal to 7 centimeters. Determine the length of OB, AO, and MC. Let's start with part A. Determine the length of OB. OB lies on DB, a diagonal of the parallelogram. So let's make this diagonal red. We know that the diagonals cut each other in half. So we can see that DO is equal to OB. And as our reason, we say the diagonals of a parallelogram bisect. The question also tells us that DO is equal to 8 centimeters. And as our reason, we simply say given. Let's put 8 centimeters onto our diagram for the length of DO. We know that DO is equal to OB. And if DO is equal to 8 centimeters, then we can see that OB is also equal to 8 centimeters. Now let's quickly take out our red diagonal, write in 8 centimeters for OB, and now we can move on to part B. Determine the length of AO. AO lies on diagonal AC. So let's make this diagonal red. The question tells us that AC is equal to 10 centimeters. So as our reason, we say given. We know that diagonals cut each other in half. So in this case, AO is equal to OC because the diagonals of a parallelogram bisect. Diagonals cut each other in half, which means that AO must be equal to half of AC. We already know that AC is 10 centimeters, which means that AO is equal to 5 centimeters. Let's quickly take out our red diagonal and we can fill in 5 centimeters for AO and 5 centimeters for OC. And now we can move on to part C. Determine the length of MC. Let's make MC red. Now this line extends past parallelogram ABCD, so we can't use opposite sides of the parallelogram to find its length. But the question tells us that AM is parallel to OM. OM is shorter than AM, so we can use the midpoint theorem. A and O both sit on line AC, so let's make triangle ACM red. Now we can say in triangle ACM, the question tells us that MN is 7 centimeters long. So we need to use the midpoint theorem to prove that N is the midpoint of MC. To do this, we need a pair of parallel lines and another midpoint. We have just proven that AO is equal to OC. We don't need to prove this again. So as our reason, we simply say proven above. The question tells us that ON is parallel to AM. We've been given this information, so we use given as our reason. Now we have a midpoint and 2 parallel lines. We have proven that N is the midpoint of side MC. So now we can say MN is equal to NC. And as our reason, we say midpoint theorem. We also know that MN is equal to 7 centimeters because this information has been given to us in the question. And we can see that MC is therefore equal to MN plus NC. We know that MN is 7 centimeters long. We also know that NC is equal to MN, which means NC is also 7 centimeters long. So we can see that MC is equal to 7 centimeters plus 7 centimeters, which gives us a total of 14 centimeters. And we have now completed this question.